Okay, we're going to be talking about this wonderful ADI BMS device here. It's the ADBMS1818 device. What we have over here is a nice battery emulator for a number of cells. And what I like about this unit is you can adjust this pot over here to change the voltage on the entire stack. There's a boost circuit, 5 volts. You boost it up to 50 volts, 40, 60, whatever you need. Those cells voltages will come in over here to the monitor device. From there, we're going to have coming out of this chip isolated SPI. So we have 2 connections of isolated SPI. That comes over to this little monitor board, bring isolated SPI in. Now we've got a Maxim MCU USB-C connector up to the PC. And once we get up to the PC, we can run some GUI software to monitor some batteries. This is the battery monitoring system evaluation platform. And this platform right here was put together by eInfoChip/Aero Electronics. And this is kind of what it looks like. You got the emulated battery cells, the monitor, BMS, and then into the MCU up to the PC. So this is the getting started instructions. Once we go through and follow all these setup parameters, we can then get this system up and going. And this BMCU board has the software inside the Maxim part here. We've got the source code off the wiki pages, so we can change things to our desire. This is what that board looks like. It's got CAN interfaces, SPI, isolated SPI, and isolation USB-C. Okay, let's go on to this next page here. See what that's about. Okay, it's talking about the monitor board. And then these are some of the features on it. And then this is the battery stack simulator. Pretty nice little board there. And we come over here for getting started on the GUI software and stuff. This is kind of what the GUI will look like. It's running, I think, Python code. Here's your references for eInfoChip's ADI and probably Aero Electronics. Okay, so from there we have some other documents. This is for getting the BMS firmware running the Maxim chip, and it's got setup instructions on how to get certain things going, tool chains and stuff. So that's kind of a handy document. And then here's your GUI user's guide in case you want to understand it and see how the calls are working for this Python code. So you can read through that documentation, get more aware of what's going on behind the scenes, behind the curtain. Okay, so over here, what we're going to do is we're going to quickly start up the GUI. And once that starts up, I've pre-configured my USB-C port to go to jump to COM9. So I'm going to go to COM9 15 or 115.200, and I'm going to hit the connect button. And over here it's going to detect we found a BMS analog front end board. Everything else is green over here on the bottom left. So we're going to come up to the tab on the AFE board number 1, and we're going to see a bunch of cells. And we go, let me come back over to this other screen. I forgot to hit the start button. We hit the start button, and we're starting to see voltages come out for the stack voltage. Right now, That's a pretty high stack voltage right here. We're at 47 volts. If I turn the pot on that emulator board, we can see the battery voltage is increasing, going up to 47 to 52 volts. And at this point, we can also start to click on and monitor all the cell voltages, or shut that off and select GPIO pins. Looks like only G3V has got something applied to it at this point. So anyway, that's what's going on with this GUI associated with the 1818 board. I think this control board can also be used with other BMS chips, if the firmware is written correctly. So let's shut this down. I'm going to close that down. And then what I'm going to do is I'm going to come over here to the Eclipse SDK, and then this has got the this project BMS Master. It is a different install of the Maxim Tool SDK than what you get off of the ADI webpage directly. So from the eInfo Chips Arrow wiki page, just follow what install instructions are out there. So once you get that project off the wiki pages, you can hit compile. Here, let's do a clean real quick. Clean project. We're going to clean it out, and then we're going to build it. And down here you can kind of see it's going to start to build with no errors. If you do this build inside of the IDE tool, download right off of the Maxim ADI page, I was seeing 16 errors show up, and that's because it wasn't the project wasn't constructed using that tool flow. So I reverted back to following what the wiki page instructions were doing. So anyway, we've got a build complete, and over here, let's see, somewhere there's should be source files. I think the source files may have got dropped in one of these directories. I'm not going to search for it right now, but you can see there is a bmsmaster.elf file in that workspace. So anyway, that's kind of everything about this environment. It's kind of nice because it's all open source, and then in your bms.main file, you can come over here and see how the firmware is starting up and initializing the various interfaces, and then jumping into the main application. Anyway, hopefully you like the video. Thank you.